In this work, we present a novel system for capturing high-quality facial geometry and appearance in a single shot, which is lightweight and readily applicable to existing photogrammetry systems, only requiring minor changes in terms of hardware. Digital humans are pervasive in today's entertainment landscape, especially in the movie industry, where it is important to create digital assets at the highest quality in order to make them indistinguishable from their real counterpart. The de facto standard in the industry is to recover facial geometry and appearance from footage of the actor captured in a controlled environment. Our method produces a set of appearance maps, namely the shading-free albedo, which captures effects of diffuse reflectance, and the specular intensity, which captures effects of surface reflectance such as skin oiliness and specular ambient occlusion. We also recover a high-resolution mesh with details down to pore levels and fine wrinkle lines. Finally, we solve for a single roughness parameter alpha for the whole face. These parameters together can be used to render the digitized actor in any new lighting environment at a high degree of realism. We built our setup to be a state-of-the-art photogrammetry system using only off-the-shelf consumer-grade hardware. Specifically, our capture setup consists of 12 DSLR cameras arranged in triplets around the actor's face for full coverage and regular flashes used in photography equipped with diffuser boxes. We add horizontally polarized filters in front of the lights following the approach of Gaussian colleagues from 2011. Furthermore, for each triplet of camera in our setup, two are arranged in stereo pairs for multi-view 3D reconstruction and polarized parallel to the incident illumination to observe both diffuse and specular signals. The remaining camera in each triplet is cross-polarized to observe specular-free information. With this design, our setup ticks all boxes for a lightweight, inexpensive, and easy to set up capture system capable of digitizing a human face at a quality on par with more complex and expensive setups. Our parallel polarized cameras are arranged in pairs for multi-view stereo reconstruction, from which we obtain a base 3D mesh from the approach proposed by Bieler and colleagues in 2010. We further fit a template mesh to obtain UV parametrization. Additionally, these cameras observe view-dependent specular reflections, thus providing constraint for resolving per surface point specular intensity maps as well as photometrically refined geometry. On the other hand, cross-polarized cameras observe view-independent diffuse reflection, showing effects of subsurface scattering, which gives skin and other highly scattering media their soft-looking appearance. Explicitly accounting for subsurface scattering allows to resolve sharper albedo maps. We formulate our appearance reconstruction pipeline in an inverse rendering framework. Given observations of an actor's face under multiple viewpoints and polarization conditions, the base mesh computed from multi-view stereo, and lighting conditions at capture time, we solve for the parameters ρd, the albedo, ρs, the specular intensity, and ns, the refined geometry, that minimize the difference between the observed signal and the estimated render for all camera views. Upon convergence, the rendered images are indistinguishable from the input observation. Our approach simplifies fitting by constraining the changes in geometry to be one-dimensional and enforces integrability of the resulting normal field, both of which help make the problem tractable under passive illumination. When fitting the albedo to the cross-polarized data, we explicitly account for subsurface scattering by modeling diffusion of light from neighboring surface points, following the approach proposed by Dion and colleagues in 2007 for texture space subsurface scattering. Here, we show the effects of subsurface scattering on the albedo. When not accounted for, the recovered albedo map lacks details compared to when subsurface scattering is accounted for during fitting. Here, we show a render of a patch of skin from the forehead of one of our subjects, rendered without subsurface scattering, which gives skin appearance a dry feel due to the high frequency of the geometry. In comparison, when subsurface scattering effects are enabled, the high-frequency details from the geometry are blurred, giving skin a more natural, soft appearance. We have already shown some results of our digital doubles produced by our system. In the following, we showcase the high quality of reconstruction of both geometry and appearance across a multitude of subjects picked to span different ethnicities, ages, and genders. We also captured these subjects performing a range of different facial expressions in order to cover as many use cases as possible. For all of them, we illustrate how the captured fine details in skin surface reconstruction and modeling of subsurface scattering effects lead to realistic renderings of their digital doubles, which match real photographs well. This example shows a comparison for the lighting condition at capture time, which is a close match. This is expected, as this observation is part of the data used for optimization. We thus further validated our approach by comparing photos and renders for unseen lighting conditions, which also shows a close match. Here, we show some of our subjects rendered in two novel lighting environments. Our method is readily extendable to dynamic capture, where we treat each video frame independently. Here, we show a breakdown of the different maps obtained using our method on video sequences captured in the setup of Gotardo and colleagues, modified for polarization-based view multiplexing. This shows the versatility of our method in producing high-quality digital assets suitable for VFX applications. In conclusion, we have presented a new lightweight face capture system for high-quality acquisition of both facial geometry and appearance. High-quality results had only been provided by more complex and expensive capture stages of restricted access. We provide a low-cost solution built from off-the-shelf consumer hardware that extends passive photogrammetry to democratize high-quality facial appearance acquisition and to enable lower-budget applications inside and outside the entertainment industry and academia. Thank you for your attention.